Okay, now time series analysis. We have actually talked about it a little bit before this one. So in the time series analysis, we need to have a look at the trend, okay? Because sometimes our instrument is also limited. Sometimes it sees something that is, for example, going up. There's like a trend going up. But sometimes if you have a look at it, it doesn't make sense. The trend should not be there. So the best one, well, some of the instruments have something that is called drift. So this drift needs to be taken care of as well. Okay, so you can imagine that this is the original data and this is actually the data that you have shifted. Okay, but there are actually some data that is just like that, that is actually shifted. For example, the data that is the sea level in different areas. So you can see that these are different graphs, different areas. They are talking about different sea levels. But you can see that the year here is very, very long compared to this one, which is just in seconds. Okay, so the key thing when you're going to detrend the data is to have a look at your time scale. Does your time scale make sense? Does it not make sense to detrend it? If there's a trend, is it real, or is this, if isn't real, stuff like that. Okay, so you need to understand your time scale, and then you can actually produce multi-layered time series. It looks like this. So instead of having a graph of lines, you actually have like a block. Okay, so for example, this is your depth dimension. Okay, this is your spatial dimension. This one is your time dimension. Okay, so this is your spatial, I'll just say S, and this is your time dimension. And the filler in here is the parameter that you're actually plotting. I think from the numbers, this could be temperature, this could be salinity. Yeah, okay, that makes sense. So you have, you can see that the trend is actually this block of water, for example, is actually going hotter and hotter. Okay, it's going hotter and hotter. But this one is actually the salinity. It is also getting more and more saline. So that's what is called multi-layer time series. And then you've got, you can plot multiple time average graphs. So instead of having your graph just like that, you can actually process it. You can average it to make, again, seasonal type of analysis. For example, we're going to talk about temperature as well. So these are the temperatures in, these ones are actually months. Okay, so you've got January, January is this one. It's quite close to 12, but it's January, and then up to December. Okay, so you can see that, from the time average graph, the warmest water is actually when it's in August, and the coldest is actually when it's in March. So you can imagine that this plot is not one single data, but multiple data, depending on the frequency. It could be daily data, it could be maybe true daily, maybe it's half daily data, but it's basically time average into one single month. And then it will actually be a very, very good information. And then there's something that is called spectral analysis, but we're not going to talk about it in details. I think if you want to talk about spectral, if you want to learn about spectral analysis, you should take the estimation approximation class. It's going to be quite interesting. It's a new class. I didn't have that class when I was in your age. So yeah, the basic of spectral analysis is actually you've got this type of observation, okay? What you want to actually do is to separate the components. The first one is you want to see like the first harmonic. You can see, I'll do another color, maybe blue. So you can see that the first harmonic in here is actually going like that. So that's your first component. And you can actually see the second component that looks like this. And then you can divide it into, how many harmonics as you want. So that's how you're going to transform the data that is in time into something that is in frequency. So it looks like this. It's basically just like a histogram. So instead of having time as your x value, you've got frequency as your x value. This one is the same, okay? The parameter in here is actually still the same with the parameter that you're observing. So the cycle itself is also like how many, for example, this one is talking about the cycle, like how many cycles per hour. Is it 1/12 cycles per hour? Is it 1/6 cycles per hour and stuff like that? So you can see that, oh, okay, this cycle is the most prominent one. Okay, so again, the basic of the spectral analysis is converting something that is time domain into a frequency domain. We're not going to talk about this, but this is a very, very interesting and useful part to analyze data. And that's it.